Standard condition. Alright? And negative n. And then we'll do a throwback to cursive days. What letter is that? Cursive what?
F.
F. T. Well, it would be a T without the little thing.
Is that J?
It's an F.
Oh, F.
It's an F. Look, there's the.
Wait, when were we supposed to use? Hey, we were supposed to learn this in the 3rd grade, right?
I don't think they teach cursive.
No.
They do.
Do you have any brothers or sisters? Do they teach cursive?
No.
They do.
We should have
I think they do at Wingwood.
We'll do cursive handwriting after.
Hey,
Yeah.
I need that. I would need that. No.
How do you know all that?
Oh, yeah.
That's so she made us do it for like the entire first month.
What?
Jory.
Okay, all right. We could do some notes. Oh, what I could do is like a contest. I'll just start talking like a professor and just go. That's what I'm gonna do. I like it. So here's what we'll do after the AP test. What I'm gonna do, I'll do an example lecture over something I studied, but I won't do it like this where I'm like, hey, everybody follow along. I'll just be talking, and you guys will, and I'll have a PowerPoint and you just write down stuff, and we'll see. Then I'll give you a test and see how helpful your note taking was. I'll teach you how to take
I don't like the sound of that.
I'm gonna teach you how to take notes.
I don't like the sound of that. Oh,
Yeah. All right. So here we go. This is Gibbs free energy. Obviously.
Shouldn't he have taught us this in the beginning of the year? Then it wouldn't it be technically better?
That's probably true, right?
Yeah.
Right. Okay. Now you've seen N before in chemistry, and it usually means what? In PivNert, it means what?
Mole.
Okay. It does still need number of moles, but now we're talking about the number of moles of electrons. Okay. Now the nice thing about this is that it is an integer, so N is equal to like 1, 2, 3, 7. Okay. So if we think back to, like in PivNert, right, you can have 2.3 moles of a gas or 5 moles. Since we're talking about electrons, right? Electrons are in certain quantums or quanta. I guess it's the plural. It's in certain amounts of. It's stepwise, right? So it's like 1 electron. You can't have 1.2 electrons or 1.5 protons, right? It's an integer-based thing. So when we're doing like our balanced, when we balance redox equations, remember how you have to like multiply each equation so it's the same number of electrons? Whatever that number of electrons is, that's what you put in for your N. Okay? So if it's like you have 2 electrons and 3 electrons, you have to multiply them out so that equals 6. The 6 would go in here. Okay? So we'll do some example equations so you can kind of see what I'm talking about, but it's the number of electrons in the reaction. So that's why we more or less do that, to see what's the net number of moles of electrons that are being transferred. Now, this is named after a homie. Starts with F. Felipe. Definitely not as cool. Faraday. Okay. So Faraday. Faraday Pratt.
That's such a big number.
I have a feeling my wife. So what would you call him for short? Fair.
Day.
Day. Oh, I like day. What a day.
What a day. Day.
Day?
Day Pratt. Pratt Day. Pratt Day. Day Pratt
Day
Day.
is my bae. Oh, I got thumbs down. Ouch. Okay. Okay. Faraday's constant. Here's what this number is. 96,000. Somebody read their book. All right. Okay. Okay. So coulombs per moles of electrons. All right. Now, coulombs, which is that word that everybody laughs at every year when I teach it, just a measure of charge. Okay. But you'll notice, right? Moles of electrons is in the denominator. So what happens when you multiply N times F? What happens? These get canceled out. So then you're left with coulombs. And then this is your cell. And then this is measured in what?
Voltage.
Volts. Okay. All right. So you have volts multiplied times coulombs. Your moles of electrons cancels out, and then that gets you Gibbs free energy, which generally is going to be something like kilojoules per mole. Okay? The unit is coulombs, which is charge, per mole of electron. Coulomb slash.
Cancel that with the number of moles.
Use what?
The N.
Well, when you do charge, I have to look at the units. But coulombs breaks down even more. Joules per mole? Okay. So let's do a quick example one so we can kind of see how this works out. Okay.
OMG.
All right, here we go. Let's do an example. We're gonna take some silver. Moment. What? Baking what for a project?
No.
We should make one.
I mean, all cooking is chemistry.
You should see who can make the best volcano.
How many? Rather than like, I added 2 cups of sugar, I added 3.6 moles of an excuse to eat, and then you do a little chemistry.
Oh wait, this is that.
I think you have to do that for like calories or something.
Yeah, for extra credit. No, that was for honors. Yeah, honors.
All right. Here's what I want you to do. Using your tabulations in the back of your book. Oh, I could have made this harder. Okay, that's fine. All right. Using your values in the back of the book. Okay. Calculate the E cell, standard condition, and I want you to calculate delta G. Okay? Take some time. Figure this out. You will need to look at the back of your book, either in stolen PDF form or
It's not stolen, it's borrowed.
Oh.
Yeah. Yeah, we're gonna borrow and then delete it
I found the flash
afterwards.
drive on the ground, Mr. Pratt, and it made its way to my
Computer, things happen.
and I opened it and used it. Officer, the 2 kilograms of cocaine. Well, they jumped into my trunk of my car, and then they found their way into the needle.
Sometimes that happens.
Wait, how do you take cocaine?
Cocaine, you snort it.
Snort it, that's right. And then crack, you okay. I need to get my drugs straight. My bad. I could ask my neighbor. He got put away for some time. But he and I are tight. He's also in the pen right now for what was the charge?
Was it an electron charge?
No, it wasn't kidnapping. It was like worse.
Oh my god. I don't want to look at it.
Yeah, it was
What was it? It was like
oh, I was trying to think of the charge. It's like really bad. It's
what was it? I heard like some
Laundering.
it was like right
Rod.
still live there?
no, he's in jail right now. He has my extension cord too. Kind of beefing about that.
Was he your homie though? Oh! You told this story! The guy was your neighbor.
Yeah, he has my 100-foot extension cord. I was telling this to Mr. Taylor.
Oh, dang.
Taylor's like, oh, you realize he's probably like holding the body like tied up with your extension cord, right? I was like, thanks, that makes me cool. What was it like?
Did you
unlawful imprisonment was the charge.
Like he locked someone up.
Like it's like locking somebody up in your house and not letting.
Is he obsessed?
This guy is like. Mad. He's like 65. It's the weird thing. I was like, dude, I could totally take you. Like,
He uses his elderly. He goes like, help me.
I got some popsicles in my cellar. Wonk. Alright, y'all calculate these two. I'm done talking about my neighbors. Thank you. It's at the end of the block.
Is it the in the block or outside?
No, it's at the end of the block.
You don't want to send your daughter over there.
No. Alright, y'all calculate each cell. You will need the back of your book.
If I haven't watched it,
I don't need to watch the movie about it.
you need to watch it.
Oh, that's cool. That's cool. I skipped on that one.
Have you watched the movie? Have you watched
I got one note on here now.
What?
One note.
Can I
Oh,
answer?
okay.
Let me put it up.
Does it work well? Let's see.
I don't know.
Show
Oh,
your. Show
okay.
your.
You gotta like press it.
Yeah, I know.
Oh.
How do you? Is it? No.
Maybe insert.
What happened to the standard?
Oh yeah, maybe it doesn't have it for iPad because it didn't have it for Android. I should try to find it.
Oh, they don't have it.
Yeah. Yep. 96485.
You assume?
Assume what?
It doesn't matter.
You should know. So, good question. If it's just Ag by itself, which is silver. Silver's a what? Solid. Okay. Oxygen. Solid, liquid, gas. Okay. Anything with a charge, you know is going to be what?
Thank you.
Oh, okay.
Another other one.
And then this is liquid. Good question.
Oh yeah. I saw the Pat,
That's a good question. I'll let you think about it.
Zama B. Something wrong.
Oh, okay. So, here we go.
She's on my beat. That's only wrong. Okay, so I saw this funny thing on Reddit. It was like a job interview, and when the interviewer asked like, "What is your greatest weakness?" the guy said that he's lazy, and then he said, "Why?" And then the interviewer said, "Why?" And then he said, "Well, I like to do things the most efficient way." Then he got the job.
Wow.
You get it? Yeah. It was for programming things. Programming job. Yeah.
Are you gonna try that?
Yeah. I mean, I'm not lying. I wouldn't be lying if I said I like doing things efficiently. Smart. Hey, Pratt, can you check this?
What's your N? 4? Okay. Yes, that looks correct.
Okay.
Yep.
Is this supposed to be a really big survey?
Yes, because your Faraday number is pretty big. I'm just checking. I think it might be a joule. Check the problem. Kit, your answer is in joules.
Okay.
So then you convert it to. BT dubs. I misspoke. This is joules. Not kilos. So if you get a big number, right, 170,000 divide by 1,000, you can put it to. Okay.
What is the F?
Well, or whatever the number is. Okay. Hey, take this overall equation, write a reduction half reaction and an oxidation, and hopefully you'll see how many electrons are added. I did see a line in case I didn't publish my Facebook.
Oh no!
One guy like trying to be like.
Oh yeah, and then he shoots it off. Yeah.
Was he like my mom?
There's some white dude with a shirt off.
No, it was that one.
Oh, it was the shotgun.
Oh.
Let's put all these in red.
It's great. Fine videos let you see the total depravity.
Then I'm gonna take it. It's gonna be like this is every one of these pages is filled with this handwriting, and they're gonna be like, oh my god, this is so amazing.
You don't have any questions?
I'm gonna get internet points. Yeah. You can get it too. You don't really get anything. It just you kind of feel good just getting points.
It should already be multiplied.
It's like whenever you play Maple Stories or something.
Figure out how many electrons.
Yeah. Like it's money, you might have like a mil or how much money do you have?
I know I was
Like above a million, 100 million. I know that high level players.
I wasn't in
Yeah. For the robot? Yeah, like we just need to finish the program, just get it running, and then afterwards we can improve it. Yeah. I saw Vladimir's robot. Theirs doesn't look that like it works. It doesn't look like it works. Yeah, I'm not sure how they're gonna get that. Yeah.
Oh, I saw that.
I'll show because I think some people are struggling. All right. Okay, real quick. I think here's what I'm seeing is a lot of people are struggling. Okay. I think people are getting the E cell. That's good. Oh man. Yeah. Okay. So I think we're getting the E. Now, a lot of questions are about this N value. How do you get the moles of electrons? Now, the thing that I gave you, okay, this is already a balanced equation. So since it's already balanced, you don't have to do that whole multiply times 2, 3, get them to match. It's already been balanced. And remember, whenever you balance a redox equation, what cancels out on the left and the right? The electrons. So they're already canceled out. You don't see them here. So it's kind of like, oh crap, they already canceled them out. I don't see them. How many moles of electrons? Now, there's a couple ways to do this. I was actually, if you could do this relatively quickly, what I would do is you can just pick one thing. So what I did is I looked at silver. Here's silver, here's silver. Okay? How many moles of silver do I have? 4. And the charge is 0. I have 4 things of silver at charge 0 that on the right-hand side of the equation, right, they're being oxidized to 4 plus. So my charge is going from 0 to positive 4. So if it goes from 0 to positive 4, how many electrons did it lose? So it lost 4 electrons, and that's equal to my 10. That's really all you have to do. Another way you could do it, if you wanted to break it down further, because a question they can ask you is they may ask you for something like, what's the reduction half reaction? What's the oxidation? Right? And since you would say, oh, well, there was 4 Ag, and it went to 4 Ag plus, right? Since this is being oxidized, right, in oil rig, oxidation is lost, so my 4 electrons are on the right-hand side. So that's another way you could tell. Or the other way, if you look back at your equation, what's the thing that actually got reduced? You're left with oxygen or hydrogen? What's the thing that got reduced?
No, hydrogen.
Okay, let's talk about this. Okay, don't think too hard. H2O. What's the overall charge of H2O? 0. So that means my oxygen, if you look at the periodic table, is usually what? Negative 2. And each hydrogen is what? Positive 1. So, but if we look on the right-hand side of the equation, I have O2, and I also have H plus. What's the oxidation number of any element in its regular state?
0.
0. And the charge of hydrogen right here is what? Plus 1. So here, I want you to see something, right? Sometimes things don't change charge. That's okay. There's a lot of reactions that happen where nothing gets oxidized or reduced. All those double replacement reactions, right, where the outsides get together and the insides, those aren't redox equations because they keep the same charge. But there's some reactions like this one. Anytime you see something in its element, so basically this is the thing to know. If you see an element, elements generally get either oxidized or reduced. Because elements will have a charge of 0, and they'll either reduce to something that's negative, or they'll oxidize to something. So sometimes you'll see like sodium metal. If you see a metal, most likely it's going to oxidize to its positive state. If you see a non-metal like chlorine, it's going to oxidize to or reduce to its anion.
It's easier to like hold on to this.
Okay, so anytime you see an element, you should really think, uh-oh, something's going to get oxidized or reduced. So anytime, any reaction you see an element in its pure form, right, solid or liquid or gas, it's going to get oxidized or reduced. In this case, we're going from charge of 0 to a charge of negative 2, and that's our reduction. It's going from O2 to H2O, and then you have your 2H plus here. So that's our reduction. Question on this one.
But that H2 is positive. Shouldn't it be
Each hydrogen's positive
plus
one,
1? But
right? And over here it's also positive 1.
In that compound, water, there's 2 hydrogens, so it shouldn't be.
Well, right. So you're right. It's 2 plus, but each hydrogen is 1 plus.
Oh, you counted like.
Yeah. So I'm looking at the oxidation of just one atom of hydrogen. Right. So you're right. Altogether, right? This is negative 2. This is positive 2. But each hydrogen, since there's 2, each one's positive 1. If you look at the left-hand side of the equation, you see H plus. It's also positive 1. So hydrogen was neither oxidized or reduced. It's the same. So no redox happened reaction there, but something had to be reduced, which was the oxygen. It went from being 0 to a charge of negative 2. Anytime you see an oxidation, something else has to be reduced. Like those electrons were gained by something else. Follow.
I think you said like this morning, but you said that hydrogen, something about hydrogen never being. Never mind, that's what we do.
Well, we'll talk about, so I'll show you what a voltaic cell for something like a gas will look like. It's a little bit different.
Do you need a closed container for that?
You do. It's a gas. It's a little awkward, but not too bad. Okay. So, but do y'all see how we got our number of moles of electrons? I think the simpler way is just picking one of the things and seeing what's the charge change. If it was just one, like this, right? How many electrons would this be? If it just goes from 1 mole of silver to 1 mole plus 1. 1, right? But since we had 4.
So it doesn't matter which element comes from.
If they give it to you balanced, it should already be balanced. So it doesn't matter which one you pick. Now, if this was an unbalanced reaction, then you'd have to go through that whole add the waters, add the acid, do all that stuff. Then it's even more work. Okay. Well,
can 2 things be oxidized and 2 things be reduced?
yes. And there is an equation where, like, it's really weird. What can happen? I forgot the name. It's a fancy name. But where nitrogen can be on like this side with like a oxidation number of this, and on the right hand side you'll have 2 different compounds where it'll make like N2, and it'll make like NO3 minus. This would be 0, and this would be positive 6. So then you have one thing that's oxidizing, and some of them also reducing. But it's still a good reaction because you still have one thing that's being reduced and one thing's being oxidized, but it comes from like the same substance. Forgot the name of it. It's a fancy name, but it's still regular redox. It's just you'll just have the same thing doing 2 things at the same.
That means you need a lot of nitrogen.
You need a lot of nitrogen.
Oh.
Yeah.
So I have like an off-topic but still chemistry-related question.
Okay.
Okay, so you know, like in this show called Arrow, there's this like this drug that makes people tell the truth. It was penta something tetrafluoride.
Hmm?
Yeah. What? How does that work?
Unless it's fake.
I don't know. Like, cause it's also mentioned in the real world.
Right.
Too. Yeah.
I can Google it. And come
Oh.
tomorrow with an answer.
Okay. No, it's fine.
No. Like truth serums, like I think a lot of ways those work. Those of you with UW bio, basically, I think it helps flood your brain with a lot of dopamine.
What is dopamine?
Oh yeah, it's the good happy.
Kind of makes you feel happy and relaxed. And it's like, you know, and it just helps relax you and make you feel happy. Not that I would recommend, shooting heroin into somebody, which also floods your brain.
Cocaine.
Or cocaine, no, that's also bad.
What about chocolate cake?
So I don't know, it's something like a muscle relaxer slash.
Use caffeine.
Well, caffeine will get your heart rate going.
But still, caffeine.
Doesn't caffeine trick your body into thinking it has energy?
It does not break down. It's a vasodilator or constrictor.
It's a dilator. I think that's the
Caffeine, come on, bio. Is it vasodilator or dilator or constrictor?
Dilator.
Make it bigger? Yeah. More blood, more oxygen. Yeah, there. Bio. Cool. Okay. So, one last thing I want to mention.
Damn.
Okay, so there's this diagram on your book. Okay, we talked about this, and we talked about this, but then we can also talk about this. Y'all remember this?
No.
Your friend from Equilibrium. Now, hold on.
Which K are we talking
Yeah, which K?
Which K, Mr. Patrick? Okay, so here's this. We just talked about this guy. Okay. So this is how you relate these two. Oh, did y'all want the answer?
Yeah.
Oh wait, the answer is
Negative.
if you do 2 sig figs,
How do you know?
Negative 1.7.
negative 1.7 times 10 to the 5th joules per mole. If you convert that to kilojoules, right, then you're going to get something like negative 170 kilojoules. Okay, did y'all get something like this? Around there? 2 sig figs? Okay. If you got 169, whatever, close enough. Okay. Okay, so this is how you relate to these two things. Now, if you wanted to get this over to k, there is an equation that links these two things together. I don't know if y'all remember this guy.
Oh. Wait.
Sounds like, oh no, something, negative RT ln k. That's a negative, okay?
It's RT over NF.
So, these are the two things that if you can get this, you can get this, then you can get this, and then get this. The reason your book talks about a third one, these are the two problems they give you on the AP test. And so, what you could do if you wanted to is, since these are both equal to delta G, what could you do?
Set them equal to
You could set them equal to each other, right? So if you wanted to, you could derive a third formula where you have something like this, and you could solve for either K or E, right? But I'm just trying to show you, right, that both of these are equal to delta G. So if you ever have to go from potential to K, you can set it up like this, solve from there, essentially. This is the one involving joules, so it's 8.314 joules per mole Kelvin. The only one, the 0.08206 is gas laws. There's atmospheres mole Kelvin. Okay.
Wait.
Noria.
It says that it's RT over NF times natural log of K.
Right, that's if you solve these together. Like if you derive that and solve for E, all you have to do then is divide by negative NF. Negative NF.
Oh, that makes sense. Okay.
Negatives cancel, so RT over NF ln K would equal. So basically, if you set them equal and you solve for this, you get that. That's all. Just algebra. Okay, so here's your homework for this evening. Okay, so day 4 is this stuff right here. I think there's 4 problems, no other sign. And then day 5, what you're actually going to be reading about is, this one's more sort of conceptual. You're going to read about 2 things, corrosion and batteries. We've already been talking about batteries. 2 different metals, 2 different solutions connected together. So you're actually going to read about lithium batteries, right? So lithium metal, you have to use lithium metal and lithium ions, all that. And I just asked you like maybe 4 questions on day 5, but you're going to have to read in order to answer the questions, okay? When you come tomorrow, do a homework quiz, per usual. I may choose 2 questions because there's 2 days. Keep that in mind. And what else do you need to bring with you tomorrow?
Money.
Oh, right. So if you get the text, if you bring 15 bucks, we're going to start doing search, but your lab notebook.
Is your face going to be on the veto?
No. Veto. Yeah.
Damn. Who veto that? And we voted for that. This is a democracy.
Lumps. Oh, yeah. 15 bucks for a lump sleeve.
Who vetoed?
I know a guy.
Wait, is it
What's our design? Again,
Talk nerdy to me.
Talk nerdy to me.
With your face?
Come on.
You vetoed that, bro. You wanted the face.
I got 99 problems, but Stoic game 1. That's going to be the
Hey.
that's really cool.
How are you gonna fit that?
smaller font.
For a small font.
I'm not putting my face on the short column here.
We have the size like
Outline
what
your face. You have that? Like an outline of your face with the glasses or something? Like, you know, the black and white with the glasses?
No, we will put it.
Yeah, it's like an animated face.
I'm not an so if you want to animate something, I don't know what an animated version of my face is.
Oh, just quiet.
Wait, didn't you have that project where you animated something?
Someone needs to make a solo.
Not my face. There's an app. Oh, there's an app. Okay.
Take your face and then it's just animated.
I'll let you. If you want my face to be honest, you have to show me a face. I'm not putting my face. You have to digitize my face. I'm not digitizing my face.